Welcome back everyone. Now we're going to learn about the virtual memory. Well, as the name suggests, it is virtual. So, what if I tell you that it is just the illusion, nothing else? So, what it is having? It's just having an illusion, illusionary memory, the memory that actually do not exist. So, it's the memory that actually do not exist. You might be wondering that how it's possible. So that's how its name is virtual memory. So let's understand the aspect of the virtual memory. What does it actually mean and what we mean with do not actually exist? Well, that's pretty much not obvious, right? Okay. So virtual memory is a concept used in some kind of large computer system that permit the user to construct a program as through a large memory space is available. But in reality, the available space is not that large. It's very small. So available space is small. This is the reality. But somehow we are having a virtual memory that shows the infinite storage, but theoretically infinite storage, and programmer can do not have to think about the memory size. It can just do whatever the programmer wants to do, and no matter how much space it is going to take. Large memory space is available, and that's the illusion equal to the total of its auxiliary memory. Thus, virtual memory is used to give programmers the illusion that they have very large memory at their disposal, even though the computer actually has a relatively small memory. As I mentioned, the address used by the programmer will be virtual address. So the address cannot be real also, so we use the virtual address. So it's the virtual addressing technique that gives us the illusion of having the infinite memory thing that I said. The set of such addresses is called address space, and the set of the physical address is called memory space. The physical address that we are having, physical address, is called as memory space. So it's the memory space, so the memory space is less, so we use the virtual address, which is address space, and that we can theoretically have infinite. Not infinite, but I'm just using the word infinite so that you can understand that if you have 1 kilobyte, you can use the 100 kilobyte program for your work. Now, that seems not so obvious how it is working. So let's try to understand its flow here. So there is a virtual address that comes in, and this is the whole cycle of it that goes from one point to another. So let me explain and listen to me very carefully for these points and just try to see those things happening right in front of your eyes. It's all just about the imagination because we are studying something that is illusion itself, so you need to be very careful in this one. Okay, let's begin. So the working is something like this. When a program does not completely fit, that is the first thing. When a program does not completely fit into main memory, it is divided into small equal sized portion called segments. So when you have something big, just cut it into small pieces. That was the first idea because it is not getting processed. So we are just making small pieces of it, small segments of it, one, two, and in this case, I have made the 5 segments. So we have 5 portions here of that same thing or same kind of the program. This is the program segments, okay? Remember this thing. The segment which are currently being executed are kept in the main memory. Let's say that our main memory can only have two segments of the program at one time. So it covers these two segments, and rest these three segments are actually not in the main memory. It is kept in the secondary storage. So as much as your secondary storage space is, that much your virtual memory can go. Once I made my RAMs working to 20 GB when I was 11 or 12 years, just to experiment that what actually happened. Well, you will not believe me, my hard disk crashed after a few days. So later I figured out the reason that because I added my virtual memory and it was not actually just 20 GB. I started with the 20 GB, then I made it 30, 40, 50, then 100 GB, 200 GB, 300 GB. Someday it gone well, then my hard disk said, no, I cannot take it anymore. Because the virtual space is actually has to be somewhere. You cannot have something that do not exist. We are not saying it do not exist, we are saying that it do not exist in the main memory right now. So it is giving the main memory the illusion that it is carrying it when it is not having it. So rest of the three goes to the secondary storage. And if an executing program needs the segment which is not currently in the main memory, the required segment is copied from the secondary storage to the main memory. From the secondary storage to the main memory, it produces the copy of it. And no matter which kind of the copy you use, actually your work will going to happen. You will not stop. You will feel like tremendous speed you are having. This process thus creates an illusion for the memory with large spaces running in small sized main memory. So you can run 100 GB space required thing if you have 1 GB of RAM and 99 GB of virtual memory. So that's the whole concept of it, and you are getting the copy of that thing again and again and again. But surely the secondary storage will get ripped off after some time, as I told you from a practical experience that it will not going to work. If you're not having very much powerful PC and you exceed your limits, it will surely going to crash. So that's actually happened in the practical world, but it is indeed useful. It is very useful. You can search in your PC or laptop that what is the virtual memory that is set. Actually it is set by default to some extent, like 512 or MB or sometimes 1 GB, and as you are having the device, in that way it is stored. So it is always kept for the backup purpose, that that it should run the bigger program also that cannot fit in your main memory. So from this diagram we can see the virtual address register is there, that goes to the memory mapping table, that goes to the memory table buffer register. Buffer means the process is going on, the circle thing that you are able to see whenever you tap for any video and it just runs and runs and runs and runs, and it is about to run. So that kind of thing. Now main memory address register is there, that goes to the main memory, and the main memory buffer register is there, that is having it to run. Well, nowhere you are able to see here the secondary storage because I have not made it. But now you know that the virtual address actually exists in the secondary storage, and that kind of the secondary storage that we have, secondary storage, is giving or creating the illusion for the primary storage or main memory or your RAM, that it is having so much space that it can run anything, and it is running two things at a time at max. So it will run two things at a time, 20 times, 30 times, 40 times, 50 times, 60 times, as many a number of times that you want. So that is the thing. Each time it is getting copied from the secondary storage to the primary storage, and then it will going to happen. This is the virtual memory. I hope you have got the entire point of the virtual memory, and with this we are finished up with our most exciting section of studying the, well, what? Can you guess? Yes, the memory part. We have covered the main memory, we have covered the cache memory, and finally we also have covered the virtual memory. So we have covered these all the things, and with this I can say that it's the ending portion for us to and the advanced computer architecture, in which we have learned about the CPU, instruction pipelining, and the various kind of the memories and their basics and their working. And with this thing, I can say goodbye for this section. We will see you in the next one, and we will learn about the digital analog communication and then the microprocessors. So stick with me, keep learning, keep growing, and take care.